Have you ever pondered the mystery of life and the universe? What if there's a designer behind it all? Welcome to the Enigma of Existence, a journey into the heart of a theory that suggests an intelligent cause behind the intricate features of the universe and living organisms. This theory, known as intelligent design, proposes that certain elements of life and the cosmos are best explained by an intelligent cause, not an undirected process such as natural selection. In the vast tapestry of scientific theories, intelligent design weaves its own unique pattern. Rather than attributing the incredible complexity of life and the universe to naturalistic explanations alone, it emphasizes the role of an intelligent agent in the design process. It's like looking at a beautifully orchestrated symphony and suggesting that there might be a composer behind the scenes, guiding each note into a harmonious whole. Now, imagine the universe as an intricate puzzle. Each piece, each star, each cell, each strand of DNA fitting perfectly into its place. Could this be the product of random chance, or is there a puzzle master who carefully and intentionally designed each piece? This is the essence of intelligent design theory. But the theory doesn't stop there. It ventures into the realm of irreducible complexity, arguing that certain biological systems are composed of interdependent parts, all necessary for function. It considers specified complexity and information, suggesting that some biological structures exhibit highly specified arrangements unlikely to arise by chance alone. And it presents empirical evidence and mathematical probability to support its claims, contending that certain biological features are exceedingly improbable to have arisen by random chance. Of course, like any theory, intelligent design has its share of criticisms and controversies. It has sparked debates about its scientific validity, methodological limitations, and the invocation of supernatural explanations. It has even triggered legal and educational controversies over its inclusion in science education. Join us as we delve into the intriguing world of intelligent design. Let's start with a key concept: irreducible complexity. This is a term coined by biochemist Michael B., one of the leading proponents of intelligent design. It refers to the idea that certain biological systems are so complex and so dependent on their individual parts that they couldn't have evolved step by step as Darwinian evolution suggests. Picture a mousetrap. It's a simple machine, right? It's made of a few components: a spring, a bar, a platform, and a catch. Each part plays a crucial role, and without any one of them, the mousetrap simply doesn't work. This is an example of irreducible complexity. Now, apply this concept to biological systems. Take the bacterial flagellum, a microscopic whip-like structure that bacteria use for movement. It's composed of numerous protein components, each playing an integral role in its function. If you remove just one part, the flagellum ceases to function. Intelligent design proponents argue that such a complex, interdependent system couldn't have evolved in a piecemeal fashion. They suggest it must have been designed in its entirety. Another example is the blood clotting cascade, a complex sequence of chemical reactions that stop bleeding when a blood vessel is injured. This cascade involves a series of proteins, each activating the next in a precise order. If any one of these proteins is missing or malfunctioning, the cascade fails and clotting does not occur. Again, proponents of intelligent design argue that such a finely tuned system couldn't have evolved step by step. But what about the counter-arguments? Some critics say that these systems could have evolved from simpler precursors, with each part initially serving a different function. They suggest that over time, these parts could have been co-opted into new roles within the complex system. This concept is known as exaptation. However, intelligent design advocates question whether this explanation can account for all instances of irreducible complexity. They point out that even if each component could perform a useful function on its own, it's still a huge leap to a fully integrated functioning system. Furthermore, the concept of irreducible complexity isn't just about the number of parts. It's also about the specificity of their arrangement. In the bacterial flagellum and the blood-clotting cascade, the parts must be arranged in a very specific way for the system to function. So, what does all this mean for the theory of intelligent design? Well, it suggests that if irreducibly complex systems exist in biology, And if these systems could not have evolved through a series of small modifications, then they must have been designed. And if they were designed, then there must be a designer. So, can these complex systems really evolve one piece at a time? That's a question that continues to spark debate in the worlds of science and philosophy. Now, let's explore another fascinating concept: specified complexity and information. This idea is a cornerstone of the intelligent design theory and seeks to address the intricate arrangements found in biological structures. Specified complexity refers to patterns that are both intricate and well-ordered. This isn't about complexity alone, as a random jumble of letters is complex but doesn't convey meaningful information. Specified complexity is about a well-defined, recognizable pattern, like the carefully arranged letters in a sentence or the specific arrangement of bases in a strand of DNA. Information, in this context, goes hand in hand with specified complexity. Think of it as the message or meaning conveyed by a particular pattern. In the realm of biology, this could be the instructions encoded in a DNA sequence or the specific arrangement of proteins in a cellular structure. Now, why are these concepts so important in the intelligent design theory? Well, proponents argue that the presence of specified complexity and information in biological structures is unlikely to arise by chance alone. They contend that these complex, information-rich structures imply the work of an intelligent designer, much like the presence of a carefully written sentence suggests the work of an author. Consider DNA, the blueprint of life. Its sequences of bases are not randomly jumbled, but are instead intricately arranged to convey specific instructions for the formation of proteins. The information content in DNA is immense, so much so that scientist Richard Dawkins once described it as more compact than any other known system. Or think about the cellular machinery involved in protein synthesis. This process involves a series of highly coordinated steps, each requiring specific molecules in specific arrangements. The complexity and information content in this process are staggering and, according to intelligent design proponents, indicative of a designing intelligence. So we're left pondering a profound question. Could such intricate design really be a product of random chance? This is the question at the heart of the intelligent design theory, and it's one that continues to stir debate in both scientific and philosophical circles. Let's examine some biological and biochemical marvels. Delving into the world of biology and biochemistry, we encounter a multitude of complex systems that appear to defy explanation by naturalistic processes alone. These systems, proponents of intelligent design argue, are best explained by the presence of an intelligent cause. Take, for example, the molecular machines within our cells. These are intricate, nanoscale structures that perform a variety of essential tasks, from transporting substances within cells to facilitating chemical reactions. The sheer complexity of these machines is breathtaking. Consider the ATP synthase, a molecular machine that produces the energy currency of the cell. ATP. With its rotor, stator and turbine-like structure, it's hard not to marvel at the mechanical precision and efficiency of this microscopic powerhouse. Could such an intricate system have arisen solely through natural processes? Or let's look at cellular structures like the ribosome. This tiny factory within the cell assembles proteins, the building blocks of life, with remarkable precision. It reads the genetic code in the RNA, selects the right amino acids and links them together in the correct sequence to form a protein. The complexity and precision of this process is mind-boggling. It's as if there's a master architect at work, ensuring that each component fits perfectly into place. And then there's the DNA coding system. This is the language of life, a code that carries the instructions for all the biological processes that occur in our bodies. The DNA code is a marvel of complexity and efficiency. It's composed of 4 chemical letters: adenine, cytosine, guanine and thymine, which are arranged in specific sequences to form words and sentences. These instructions guide the formation of proteins, the regulation of genes, and the replication of DNA itself. The level of detail and precision in this coding system is astonishing. It's like a meticulously crafted software program, far surpassing anything we've been able to create. Each of these examples, molecular machines, cellular structures, DNA coding, demonstrate a level of complexity and specificity that seems to hint at design. They are like masterpieces of biological engineering, each component intricately crafted and precisely positioned to perform its function. Now, it's important to note that these examples do not prove the existence of an intelligent designer. They merely suggest the possibility. Science is about seeking the best explanations for the phenomena we observe in the natural world. And for many, the best explanation for the complexity and specificity we see in biology and biochemistry is that of intelligent design. These marvels of nature seem to hint at an intelligent designer, don't they? Numbers don't lie, or do they? This question forms the crux of our exploration into empirical evidence and mathematical probability as they relate to the theory of intelligent design. Let's dive into the world of probability first. For those unfamiliar, probability is a branch of mathematics that deals with the likelihood of certain events occurring. It's a way of quantifying the uncertainty inherent in predicting outcomes. Now, one of the key contentions of intelligent design is that the probability of certain complex biological features arising by chance alone is astronomically low. To illustrate this, let's consider the simplest life form we know of, a self-replicating protein. The odds of even this most basic life form forming by chance have been calculated to be 1 in a number with 40,000 zeros after it. That's a number so large it's hard to even comprehend. But let's put it into perspective. The number of atoms in the observable universe is estimated to be a number with only 80 zeros. So the odds of a simple protein forming by chance are many, many times less likely than picking a single pre-chosen atom out of all the atoms in the universe. This is just one example. The mathematical improbability extends to other complex biological systems as well, such as the eye, the wing, or the bacterial flagellum. Each of these systems, proponents of intelligent design argue, are so complex and so finely tuned that they could not possibly have arisen by chance alone. But what about empirical evidence? Well, this is where things get even more interesting. Empirical evidence refers to information that is gathered through observation or experimentation. In the realm of intelligent design, empirical evidence often comes in the form of biological structures or processes that are best explained by an intelligent cause. For instance, the information content in DNA, which is densely packed and intricately arranged, is often pointed to as empirical evidence of intelligent design. The argument is that such a high level of information content and specificity could not have arisen by chance alone. But as with any theory, it's important to keep in mind that these are interpretations of the data, and interpretations can vary. Different scientists can look at the same piece of evidence and draw the different conclusions. That's the nature of science, and it's what drives the ongoing debate and research in this area. So, where does this leave us? Well, when we consider both the mathematical probabilities and the empirical evidence, it seems clear that there are aspects of life that are incredibly complex and finely tuned. These features appear to be highly unlikely to have arisen by chance alone. The odds seem to stack up against chance, leading some to propose a designer. But as with all scientific theories, the quest for understanding continues. Every theory has its critics. Let's hear them out. Intelligent design, like any theory, is not without its share of criticism. The primary objections revolve around its scientific validity, methodological limitations, and the invocation of supernatural explanations. Let's delve into these controversies to gain a broader understanding of the ongoing dialogue around intelligent design. The question of scientific validity is a significant bone of contention. Critics argue that intelligent design fails to meet the criteria of a scientific theory. Unlike theories such as evolution, which make testable predictions and are open to falsification, intelligent design is often criticized for lacking these fundamental characteristics of science. Critics suggest that intelligent design doesn't offer a mechanism or a way to test its claims empirically, leaving it open to the criticism of being unscientific. Moreover, the methodological limitations of intelligent design are also under scrutiny. Critics argue that the theory leans heavily on the argument from ignorance. This fallacy occurs when one concludes that because something cannot be explained, it must be the work of an unknown designer. Critics assert that just because science can't yet explain certain complex biological phenomena, it doesn't mean that an intelligent designer is the default explanation. The invocation of supernatural explanations is another common critique. Critics point out that referring to an intelligent designer opens the door to supernatural explanations, which are outside the realm of empirical science. By invoking an intelligent designer, the theory moves away from the naturalistic explanations that science is equipped to study. For some, this shift blurs the line between science and philosophy or religion, and they argue that it undermines the theory's scientific credibility. Finally, there's the ongoing debate over whether intelligent design should be classified as a scientific theory at all. Some argue that it's more a philosophical or theological argument than a scientific one. They point to the lack of empirical evidence and the reliance on untestable assertions as reasons to classify it outside the realm of science. However, proponents of intelligent design argue that it does provide a valid scientific framework for understanding the origins of complex biological systems. The discussions around intelligent design are complex and nuanced. Critics and proponents alike bring valid points to the table, and these debates contribute to the ongoing evolution of our understanding of life and the universe. As we grapple with these big questions, it's important to remember that criticism and debate are the lifeblood of scientific progress. Through this process, we refine our theories, discard what doesn't work, and inch closer to the truth. The debate is fierce, but it's the questioning that drives us closer to the truth. When theories clash, the courtroom often becomes the battleground. This statement rings particularly true when discussing the legal and educational controversies surrounding the inclusion of intelligent design, or ID, in science education. Across the globe, the question of whether ID should be taught alongside evolution in science classrooms has ignited fiery debates. Those in favor argue that teaching ID encourages critical thinking and presents students with alternative perspectives on the origins and development of life. However, critics contend that ID is not a scientifically valid theory and therefore has no place in a science classroom. A noteworthy case that encapsulates this controversy is Kitzmiller v. Dover, which unfolded in Pennsylvania in 2005. Here, the local school district mandated that students be informed about ID as an alternative to evolution. This sparked a lawsuit, with parents arguing that ID was a form of religious creationism and thus violated the separation of church and state. After a thorough examination, the judge ruled in favor of the parents. The verdict stated that ID was not science, as it failed to provide testable hypotheses and relied on supernatural explanations. This landmark case set a precedent, influencing how science curricula are shaped in many parts of the United States. Yet the debate is far from over. The struggle over ID's inclusion in science education continues to simmer, with arguments centered around academic freedom, the nature of science, and the separation of church and state. In some regions, lawmakers and educators still push for ID's inclusion in school curricula, asserting that it promotes intellectual freedom and critical thinking. In the end, the controversy surrounding intelligent design in our classrooms is not just about science education. It also touches on broader themes of religious freedom, the role of education in shaping societal beliefs, and the boundaries of scientific inquiry. Whether science or philosophy, intelligent design has certainly sparked a thought-provoking debate. This controversy, while challenging, also invites us to consider the nature of knowledge and the role of education in our society. So, where does intelligent design stand today? Intelligent design currently finds itself in a fascinating crossroads. Within scientific circles, it remains a contentious topic, with many scientists maintaining that it does not adhere to the rigorous methodologies of empirical science. Despite this, it continues to spark interest and debate, demonstrating its enduring influence in the discourse around life's origins and the universe's structure. In educational institutions, the place of intelligent design is similarly controversial. While some argue for its inclusion in science curriculums as an alternative perspective, others contest this, asserting that it blurs the line between science and philosophy, potentially misleading students about the nature of scientific inquiry. However, It's important to note that intelligent design's trajectory is not solely defined by these controversies. The theory is also driving fascinating research directions. For instance, some proponents are investigating the concept of fine-tuning in physics and cosmology. The idea that the universe's fundamental constants and laws appear precisely calibrated to allow for the existence of life. Moreover, the theory of intelligent design is prompting fresh conversations about the nature and limits of science itself. It challenges us to consider what counts as evidence, how we interpret complexity, and where we draw the line between natural and supernatural explanations. One thing is clear: intelligent design, whether one agrees with it or not, has undeniably prompted us to ask deep, probing questions about our world. It has fueled a rich dialogue that spans not just biology and cosmology, but also philosophy, theology, and education. It invites us to grapple with the profound enigma of existence in all its baffling complexity and intricate beauty. Looking ahead, the future of intelligent design is as unpredictable as it is intriguing. As new discoveries are made, and as our understanding of life and the universe continues to evolve, the conversation around intelligent design will no doubt adapt and shift. As we continue to unravel the mysteries of life and the universe, who knows what we might discover next?